Assalamualaikum dan salam sejahtera. Bertemu lagi dalam channel Cikgu Khairul, channel yang memuatkan video-video menarik matematik pra-universiti. Jangan lupa untuk like, share, komen serta subscribe channel Cikgu untuk mendapatkan video-video yang lebih menarik. Jom kita tengok apa yang akan terkandung dalam video pada kali ini. Baik, kita bertemu kembali dalam topik vectors. So, kita nak tengok apa pula subtopik kita pada kali ini dalam tajuk vectors ini. So, untuk video kali ini, cikgu akan berbincang tentang vector product ataupun nama lainnya adalah cross product. So, objektif untuk pembelajaran dalam vector product. So, kita tengok first one, find the vector product ataupun cross product. Use the properties of vector product, find the area of parallelogram. Okay, so dalam video ini cikgu akan fokus pada objektif A dan objektif B dahulu, dan baru kita tengok how to find the area of parallelogram. Okay, what is vector product ataupun cross product? Okay, let's say if theta is the angle between vector A and B, then A cross B equal to magnitude A magnitude B sine theta times vector unit. Okay, where n is a unit vector. Since vector unit or magnitude of vector unit is equal to 1, then the magnitude of A cross B equal to magnitude A times magnitude B sine theta. Okay, let's say if we have two vectors A and B, x1i, y1j, z1k, and also b, x2i, y2j, and z2k, then A cross B equal to, so we have to cross A and B. We find the determinant. So this one I, j, k. So I refer to coefficient of I, so x1 and x2. J, the column J is a coefficient of component J, and column K or third column represent the coefficient of component K. Then we find A cross B, also called as normal vector to the plane, consists the vector of A and B. Okay, let's say we have a plane, okay, vector A and vector B. When we cross this one, A cross B, we will get normal vector. Okay, the red one is normal vector to the plane, which is perpendicular to the plane. This A cross B is perpendicular or 90 degree or orthogonal to the plane. Okay, every plane have their own normal, and normal must be 90 degree or perpendicular to the plane. Okay, right hand rule. Okay, if we use this kind of right hand rule, then we see this one is A, this one is B, so we cross A and B, then we get the normal vector. So if A cross B equal to 0, then A and B are parallel. So different from dot product. Dot product A dot B equal to 0 means perpendicular. For cross product, A cross B equal to 0 means A and B are parallel. Okay, so this is the rotation of I, j, k. If you can see, I cross j, we will get k, j cross k, we get I, k cross I, we get j. Okay, then j cross I, this one for clockwise. If anti-clockwise, okay, you get negative. Example, j cross I, you get negative k, k cross j, we get negative I cross k, we get negative k. Okay, turning clockwise, the product is positive. Turning anti-clockwise, the product is negative. Okay, properties of the vector product, okay, or cross product. If A, B, and C are vectors, then this is the first property. A cross B equal to negative B cross A. Remember vector products, just before this we learn scalar product. Two vectors multiply, then we get scalar. So vector product, we have two or three vectors. When we multiply both vectors, we will get another vector. Okay, A cross B vector, then equal to negative B cross A. Okay, this one vector, this one also vector. So A cross B is not equal to B cross A because this one is not a scalar. This one is vector, so different. Okay, so be careful, bear in mind the difference between vector product and scalar product. So this one scalar. Okay, M A cross B equal to M A cross B. Okay, equal to A cross MB because M is scalar, so it doesn't matter. Okay. Then properties 3, properties 4, 5, and 6. Okay, this one are quite familiar. So how we want to use is to show the question or to prove something using the properties. Example 10, let's say we have two vectors, A, I plus 2j plus 3k, and B equal to negative I plus 3j minus k. So find A cross B. So we have A, we have B. So substitute, we find the determinant, like we find the determinant in matrices. So I, j, and k. So for component I, we have 1, 2, 3, vector A, and vector B, negative 1, 3, negative 1. So 1, negative 1, component I, 2, 3, component J, 3, negative 1, component K. So we rewrite like this one. Then we find the component I. How to find the determinant this one? We close the I column. Okay, close this one. Then we on the left 2, negative 1, 3, 3. So for vector or component J, we close the J column. Okay, then we close this one, second column. So we only have on the left 1, 3, negative 1, negative 1 for J, and the column K, we close this column. Then we have 1, 2, negative 1, 3. Okay, and the sign is positive, negative, positive, like determinant. Okay, then simplify for every single component. Find the coefficients. 2 times negative 1 minus 3 times 3, so we get negative 11. 1 times negative 1, negative 1, minus 3 become 2 plus 3. So 1 minus 3 is positive 2, but we have sign negative here, so negative positive become to negative. And this one 3 minus 2, because 1 is negative 2, so 3 minus 2, then we get 5. So this is the A cross B. Can we see this one? Vector cross vector, then we get another new vector. Okay, so this is what we call cross product or vector product. The result of cross, you get the new vector. Okay, prove that A cross B is a vector perpendicular to A. Okay, now we have to show A cross B. We just find in equation A cross B dot A equal to 0, because we want to show that A cross B is a vector perpendicular to A. Okay, so perpendicular, we need to use dot product. Okay, A cross B, one vector, dot to vector A. Okay, then we have to show that the result equal to 0. Okay, A cross B we have found at equation A, negative 11i minus 2j plus 5k, and vector A in equation. So we just multiply the common component I, j, and k. So then we get negative 11 minus 4, which is negative 8. Negative 11 minus 4, negative 15. Negative 15 plus 15 equal to 0. So we can say that A cross B is a perpendicular to vector A. Okay, clear? So we have to show A cross B, new vector, dot with vector A, we will get 0. Then we can say that A cross B is perpendicular to vector A. So next example, find a unit vector normal to the plane containing points A, B, and C given. Okay, so now vector normal. As we discussed in previous slide, normal vector is perpendicular to the plane. Okay, normal vector perpendicular to the plane. So to find the normal vector, we need to cross vector A and vector B. But for this case, vector given in the point, so we need to find what is the two vectors on the plane. Okay, let's say this is a plane. So we have point A, point B, and point C. Okay, so we have to find two vectors, either vector AB and vector AC, or we can find vector BA to vector BC, or we can find vector CA and vector CB. So it's up to us to find which vector we want to use. Okay, let's say we choose A as the initial point, so A to B and A to C. Okay, from the same initial point. Okay, so B and C become two terminal points. So we have to find what is vector AB and what is vector AC according to the position vector. So AB equal to 2i plus 2j minus 2k. How to find AB? OB minus OA. This one OA, this one OB, this one OC. So OB minus OA. So 3 minus 1, we get 2. 1 minus 1, we get 2. 0 minus 2, we get negative 2. This is vector AB. Same, we have to find vector AC. So A and C, so negative 1 minus 1, we get negative 2i. 2 minus 1, we get 3, and negative 3 minus 2, we get negative 5. Now we have these two vectors, AB and AC. To get the normal vectors, which is perpendicular to the plane, we need to cross AB and AC. So the normal vector is the result of cross product between AB and AC. We did it like this one. So 2, 2, negative 2 represent vector AB, and negative 2, 3, negative 5 represent vector AC. Then again, we close vector I or component I to get the I value or coefficient of I. We close column or component J to get the coefficient of J, and also we close component or column K to get the coefficient of K. Okay, so the vectors we get negative 4i plus 14j plus 10k. Okay. But the question asks to find a unit vector normal. Okay, now we have the vector. Unit vector is the vector divided by its magnitude. So from here we need to find what is the magnitude of normal vector. So negative 4 squared plus 14 squared plus 10 squared. This is coefficient of I, coefficient of J, and coefficient of K. So we square for each coefficient, and we total, then we get square root of 312. Therefore, the unit vector normal, the vector itself is 4i plus 14j plus 10k divided by square root 312, the magnitude of vector n or normal vector. Then we split according to the component. So negative 2 over square root 78 plus 7 over square root 78 plus 5 over square root 78k. So this is what we call unit vector for normal or unit normal vector. Okay, so that's all for this video. Jangan lupa untuk like, share dan subscribe channel Cikgu untuk video-video PDPC seterusnya. Terima kasih.